So, today we have a topic about monitoring, alerting your GVM machine, and what to do if you consider it crashed. By crash, it's different for every use case. It can be total crash, like you have a heap dump. It can be full GC, or just a latency increase in your application. Whatever you choose. But it's crashed in your use case. The idea is that you have a tuned machine that you are considering it works well. And you want to track its liveness over time and diagnose problems in advance or after the crash. Okay, as Kirk is here, so one thing you can use GC logs. In our experience, GC logs are very useful for tracking a single life cycle of machine. But in case of Sensum and even streaming Sensum, you sometimes would like to have a time series database with a historical data. Probably, but there is another interesting point about difference when you view it in GC log analysis and when you view it in time series database, as you are getting retention of data in time series database, and sometimes with bigger retention windows, you are getting clearer visibility of how health really changes, like how heap increases over time. And so what can you do to alert you? So for example, what we tried to do, we track our memory usage with JSTAT, feed it into a time series database, and in our case we consider a crash a full GC event of Q1. It's a crash for us because it takes seconds, and seconds are bad. Milliseconds are good. So that's a crash. What to do next? You have a running machines. So one thing we try to do, we enable class histograms if it crashed multiple times. Another thing we try to do, we try to print thread dumps if it crashed, because we don't have real-time profiling on production. So
you're asking me a question.
yes.
Okay, I didn't pick up on that so quickly. Oh, awesome. Okay. Well, you know, full disclosure, we do write tooling that does, well, we're monitoring your systems right now, like full-time in terms of memory, so that you're using JSTAT to get data, to collect data that you're already collecting that you can already view is sort of interesting from my perspective, because, you know, that's probably not a conversation we want to have here. That you've basically been applying random diagnostics to try to get information to help you solve some random problem. Seems like you probably are setting yourself up to get a random result. And I think, you know, the other product we do is, well, it's essentially live profiling in production systems or production profiling live production systems. And to do that, you need to be very careful about what you're doing, because if you do it the wrong way, obviously, I mean, the reason why you can't use generalized profilers in production systems is because poor sampling techniques, the effect of the sampling techniques on the runtime, and basically this whole thing that you get, they're collecting lots of data that may or may not be relevant to the particular problem that you're trying to solve. And so in your case, you're collecting much less data, but it doesn't seem like the data that you're collecting is actually relevant to the problem that you're having. And you see cases where, for instance, you'll get like run-ups in memory, heap occupancies, and then you have to look at the condition at the end and say, like, okay, if I really am utilizing all of that memory, then I basically degenerate into this condition where I run a full GC. The full GC should most likely fail to do what we expect it to do, which is collect memory, because as long as the memory is referenced, and if you've been making valiant attempts to collect it prior to, and you're not able to collect it, as long as it's referenced, then the full GC should have the same effect as all the other collections. It should fail also.
So, but maybe you have just a temporal retention.
But what happens in your case is that, it doesn't want me to talk anymore, so. What happens in your case is that the full GC doesn't fail. It may take a long time, so so you have a reasonable definition of failure, because now you're kicked out of clusters and whatever, but it doesn't fail, it succeeds. And so you're saying, okay, well then let's do a class histogram on the termination of that event. So all of the data that you probably would need has now been successfully garbage collected out of the system.
Sometimes yes, sometimes no.
It's gone. It's all gone. Every bit of it.
If GC was
The whole condition that caused your system to degrade is basically over. It's finished. Which means that it's like trying to diagnose, I don't know, an infection after you're successfully fought it off.
Yeah, but if you do the class histogram before the full GC, you have some information to understand why we may have some information to why the full GC was triggered.
So you enable class histogram. You don't do it. You enable if you go to, let's say, full GC events, and you hope as you go to, it will be the third one.
We are using this, there is an option that's saying print class histogram before full GC.
Yeah, absolutely.
So that's very, I'm using it.
I would do it.
It's very convenient to use when there is this, if you don't want those full GC events, it's very helpful in post-mortem analysis to see why we get to this condition.
Yeah, but think of it this way, right? If the full GC has just completely knocked out all of this data so that your occupancy returns to some normal level, I think there's a bigger question to ask. It's like, why did all of the previous collections to capture this data actually?
It depends on the collector.
Why did they fail?
It depends on the collector, because
I don't think so. I don't think so.
I think so, because if it's the para GC, it's because you may have some premature promotion, and it's maybe also because your application is doing like this, and you're reaching full GC, it's because maybe there is some too much allocation or whatever For G1, I think
Let's
it's
constrain the
different.
problem. Let's constrain the problem to G1 because then it gets.
Of course.
Because okay,
It's different for G1. I
Because the
agree.
parallel collection is one thing, the CMS collection is another thing.
It's still the default for
So
GC. So.
specifically, I think what, and maybe this is too specific to Justine's production environment, but it's a problem that we're seeing in the G1 across many different runtimes. Is that you do get sudden run-ups in heap utilization that will eventually degrade into full GC, after which your occupancy returns to normal.
Yeah, sure.
And that's not normal. That shouldn't happen.
Maybe fragmentation about the region or too full. I don't know.
I think we're actually looking. I think we're actually looking for a bug in the G1. Is what we're doing.
Maybe. But,
So
that's why I'm using Yazoo.
So I think, like, you know, I get heat dumps from people and they say, you know, we get all this stuff collecting in RAM and you actually, or in heap, and you actually go through it with some queries and things like that, and you find that like these things are not rooted.
And just a question, because you said Samsung has no historical data, but there's tons of historical graphs showing you the allocation, utilization, and blah 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 blah.
Oh yeah.
So what's
it's
not live.
No, it's
not live.
No, it's okay.
Samsung is a perfect tool. I didn't say any better for analysis of your GC log. That's a period. But why you want to get a time series database is for viewing a change over, let's say, 3 months.
Right. So
You
So
want to get
generally-
historical data of half a year, how it changed. So, because some changes are very like this. It just happened, but some changes are very gradual.
Yeah, so you
Like
want
something goes down,
real
down.
graphs for years and years, but it's really months.
Not years,
let's say months.
okay, but let's say from month, you want to see was there any change.
What do you want from those graphs? What information do you want to extract from this? What is valuable for you?
At least the trend of your further tuning. Will you need more memory, for example?
So you're talking about capacity planning.
I
that
don't think
case.
you need to go that far in the historic to someone just a week is enough to get a trend of what you're needing and what is
a
working
week
set.
is a very short time in production.
It
So
depends on
you
the
actually
systems.
may have very significant different load every day, for example. You have a peak on Monday, for example. Yeah, so you really have to compare Mondays. You can't compare Monday and Friday. That's totally different. You know.
I would say first thing to look for if you have some history.
You should take a chair.
Oh, sorry.
Yes.
If you made a change to the application, if it's not a trend, but if it's a spike, probably you made a change to your application. Or maybe your customers change their behavior. Because the fact that you have an application out there, it takes some time to get used to it and to use it. And maybe that's a cause of the, and you need some statistics, other statistics, not part of the GC, to realize that application behavior changed.
Yeah, sometimes you can even just match it to your Git log.
Well, like you mentioned, Mondays or Saturdays or holidays or whatever. So if you can correlate it, that's one thing.
Yeah, I would like to support your point. We have an experience of running a rather large system in Java, about 9,000 servers. And we do collect both system statistics from operating system, from JVM, and also we heavily rely on statistics gathered from inside the application. So basically, every operation we do, we measure number of operations, the average time of operation, the percentiles of duration of that operations, the number of failures, and so on, and collect this data over time and keep it for 1 year at least.
Why?
Yeah, because we need them in our incident analysis. For example, there are even season changes that users are less active on in summertime with our sources than in winter time or on holidays. And it's a regular thing that spikes on our service graphs correlate with graphs from JVM or from operating system. So whenever we see a spike on a GC graph, we go back to our service logs to see which database request or which remote service call cost this, probably cost this.
So, another thing that you can, if you have your application data with your data like GC times and response times, you can match, let's say, increase of your GC time to increase, let's say, in connection pool growth.
Exactly.
For example, in active connections. So sometimes we need more metrics to detect, let's say, the
I'm going to
cost
ask
of
why
retention.
again. I don't understand, because like, I mean, historically, information might be interesting for, I don't know, historical reasons like that, but I'm really interested in the here and now. What is the state of things now? What are the things that I have to deal with now? Those are the conditions that I have to tune the system for that are happening here and now. Historically, it might be interesting to see what things were like in the past, because it's just like I'm interested in looking at Aptera here, it's an interesting village and things like that, but it has nothing to do with the here and now. And if I'm tuning the system, it's the here and now that I'm interested in. If it's for capacity planning and looking for trends and stuff like that, I understand. But if it's for incident diagnostics and tuning purposes, really, this is a situation that's here and now, and the data that's here and now is the data that's important to me. The rest of it, I don't care about. I never have, and I can't see any reason why I ever will.
Imagine that there was an alert that some threshold was reached, and you want to understand whether it was some immediate course or the system was degrading gradually for over a half a year. And if, for example, it reached this threshold in a half a year, then it can probably add more memory and leave it for another half year without taking any further actions.
I'd like to support I'd like to support Kirk's point, because I'd like to know your success rate of if you are looking at incidents and looking at historical data. What is your success rate of finding the root cause? Oh, thank you. This is what I want to know. How's your success? How do you find the root causes, or don't you find the root causes based on the historical data? Because if you look at the GC and find out GC was a problem, the root cause might be way before, long before the GC failed.
But that's still going to be here and now. And what I mean by here and now is if you're in a single business cycle, whatever that is, like 4 hours, 1 day,
Yeah, sure.
9 days, that's now, right? And that's what I care about. I don't care what happened last year, because that's last year. That's not relevant to any incident investigation that I'm engaged in right now. We don't look at historical data. We look at comparisons with previous runs as we run experiments, but that's about as far as I go back in the past, because everything has changed in the past, and because it's changed in the past, any decision I'm making in the future is not going to be based on anything that I'm doing in the past. It's going to be based on the data that's facing me right now.
But Kirk, suppose they made a change in the application and introduced something which...
Then we'll see that here and now, and we'll deal with it here and now.
Yeah, but if they have these statistics and it started 3 days ago, and that's the time they put a new function in,
Yeah.
then it immediately points the finger at that change.
Right, but also the any diagnostic process you do will point the finger to that part of the code and that change. Anyways, the historical reasoning for whatever the incident was is that we made this code change 3 days ago. It doesn't change my diagnostic process at 1 iota.
Good.
And if I look
that's a point which was worthwhile explaining.
Okay, thank you. I'm glad you could draw it out then.
But
yeah.
Oh, I honestly didn't know. I asked.
Yeah, I mean, the point is like, what are you going to do? You're going to look at the changes yesterday, the changes the day before, change the day before to figure out if maybe there was a change.
No, you answered that already.
Yeah, I mean, it's just not an efficient way of dealing with things.
That was my question about the success rate.
Yeah.
So what's the rate? How do we find the root cause?
Well, if you see that the problem began half a year ago, you go back that time and see what was happening. But half a year ago it wasn't a problem because you have enough memory or enough CPU resources.
So what I'm questioning is your diagnostic process, because I don't care what happened to half a year ago. I've never asked a client what happened to half a year ago. I have never been paid to figure out what happened to half a year ago. I've always been paid to figure out what happened now or what's happening now, and that's what they care about. And for that, you need a strong diagnostic process. And later, if you, for historical reasons, you want to find this stuff out, if you get the data, fantastic, you can have fun. But I would differentiate that this is fun, and I think there's some confusion here in, I think, the role of historical data in terms of using it for trending and actually finding any use for it in diagnostic processes, because we know what healthy systems look like. They meet your SLAs. We know what unhealthy systems look like. They don't. It's as simple as that. So the question is now, is your system meeting your SLAs?
I think the more basic question is, what do you mean by the system crashed? And
Well,
if you mean out of memory, and then the fact that half a year ago, when you had a lower load, you didn't get an out of memory, doesn't mean that it worked okay. Just you had enough memory and it grew and grew and grew until it crashed.
yes.
So, as Kirk's
Yeah.
that's bad names. As Kirk said, okay, he doesn't care. He looks at the logs of the crash and tells you why. And the fact...
More memory.
No, maybe...
What do I keep telling you all the
Maybe
time?
yes.
Maybe you need more memory.
Maybe yes, maybe no. Maybe there's a routine which grabs memory and never releases it. A memory leak, yes.
Okay, but that's a memory leak, and that's a different diagnostic, and it has a different diagnostic process, and but the root diagnostic process is pretty much always the same. If you're applying a diagnostic process with rigor, you're going to start from known points, and you're going to progress through a process, and it should lead you to the same problem. The historical data in that process doesn't really play a role until afterwards, if you're looking to blame somebody.
But maybe it can reveal, let's say, correlation between your GC times and number of active database connections.
I know the correlation between, what these correlations are going to look like, right? So, and the diagnostic process should reveal that anyways. It should point you in that direction. The thing is, what most people, and this is a real problem, this is a huge hole in our educational system, is that no one teaches in any university, well, yeah, pretty much no one teaches in any university anything close to a diagnostic process. And because of that, we make this up on our own as we have to in order to cope with the issues that we have to cope with in production systems. And I would say this, from my experience from running workshops, is that there's probably less than 1, maybe 2% of developers actually have any form of diagnostic skills. And I know that because I give them problems and I watch them walk through the problems. These are not hard problems, these are like simple problems. And the only reason they can't solve it is because they come to the table with no diagnostic skills, and when they look at the signals that they're given for the systems, they completely ignore them because they don't know how to put them in the context to actually read them, right? So if you actually work on the real problem, is that recognizing that, you know, you may be very creative, good at defining really good algorithms and all that stuff, that doesn't mean that you have any diagnostic skills at all. And actually what we find is the more creative you are, generally the less inclined you are to come to to actually have these skills, right? And if you look at operations people, as a matter of fact, you see that I would say that, you know, we have maybe 1 to 2% success rate. You know, I think Henri has gone through this experience also. He's failed, you know. You did, don't worry. And that's okay. It's part of the learning process. But if you could put operations people to the same test, you'll get only about 70% of them succeeding. You know? But if you can correct that particular problem, you're going to see that all of a sudden the historic data that you think that you need in order to do diagnostic work, you can find it's just basically a distraction, and it doesn't really help you get to the root cause of what's affecting you right now.
So what does?
What does? Having good, strong diagnostic skills, which requires having strong mental models and understanding what's going on in the system, and be able to take the signals and apply them to those models to understand what's going on in the system to find root cause.
Read Sherlock Holmes.
Sorry? It's not read Sherlock Holmes. I mean, this process of diagnosis is a diagnostic process, right? Which is one, it's not, I'm not going to say it's the only way of doing it, but it's the one way that we have of doing it, and that's what we actually have implemented in machine learning. And so we can actually have our application actually do the diagnostics, which is illuminate in this case, right? Trying not to be commercial here, sorry about that. But the point is that if you can get a diagnostic process that has that much rigor in it, that it becomes almost prescriptive, then even though it may not be imperative, you can actually use techniques to encodify it into software. And that's what we've done. So really, I mean, you know, so what you're missing in this case is really the diagnostic skills. Okay, sir.
No, I was serious about reading Sherlock Holmes because it's exactly the Sherlock Holmes is doing his investigation exactly like you should debug or tune your code. And it's true that what is relevant is what happened now. So I'll give an anecdote. I had a CIO at some point. He was asking me if to do some capacity planning on their new application. So what they were doing, they had an old application and a new application. They were doing exactly the same thing. And the old application was able to stand the load, and he wanted to know if the new application would be. I told him it's not. And he wasn't able to believe me because it's new and the old application was working. Yeah, but it's slower. I've benchmarked it and it's slower. That's not possible. That's the way it is. And he wasn't able to cope with the fact that yes, something could be now slower, and all the history doesn't matter. I had one application here. I look at it. I'm looking at it, and it's just slower. It's the same with memory. Yes, memory over time might be used a bit more because you have more load on your application. At that given moment, if it fails and the memory goes too high, it's too high now. So the question is why? So am I having it's Christmas and I'm having a particular load at that moment, so it just crashed and I'll get over it and I'll plan for next year? Or is it the new version that we just delivered that is behaving badly? I need to find out, but it's still the now that is interesting. Like we could talk about memory leak, but memory leak you will see it like if you have 1 week, let's say, of logs. In general, you will see a really slow leak. I don't know. What's the slowest leak you've encountered?
What's that?
What's the slowest memory leak you've encountered?
Every application on the planet is leaking.
Yeah, but like 6 months leaking, or in a week you should see it on a graph.
Yeah, it takes about a week or so.
Yeah. Okay.
Few megabytes days.
So, yeah, and my diagnosis in general is just I look at what's up here. Of course, sometimes you have weird stuff, so I think I failed once, in fact, to find out what was the issue. Because there was something, and because I didn't follow the diagnosis I should have. So I did, like, I had the clues correctly, and then I ignored the clues, and I went wrong, and so they found it some kind of other way by luck, which is generally how they found it. Because there was a peak like 5 minutes every day, and they wanted to know why there was some weird peak like that. And it's because there was a virtualized system, and something else somewhere else was just killing the system at that moment. And I should have told them that, in fact, because it wasn't possible that their application was causing the problem. So I should have stopped there and say, it's underneath. Just deal with it, or give me the information to do the correct diagnosis. But it's underneath. I cannot help you anymore. It's the only time I haven't found a problem doing what I'm doing.
In respect to what you were saying, that you were capturing your logging information in time series, right, to kind of reflect upon to see if there was any kind of regression. Now, I think there's value in doing that from one perspective, which is resource planning. So you can see over the year as your business grows, right, and what kind of hardware profile you had and what you might require. Now, unless you're capturing what were the features that you committed at a certain point of time alongside with your metrics in your time series. For example, you moved from a relational database into a NoSQL database. Obviously, your memory model might increase. So if you're not capturing those defining moments, then looking back at your data will not give you a lot of insight, right? The other thing is also your application is not running on an island. It's not an island, right? It might be a chair in the living room. So are you capturing also alongside all the different versions of the software that run alongside your application? Are you also capturing with precisely the versions of exactly which Java virtual machine you were running your software on? What was the version of the Linux kernel that was running, right? So one way to troubleshoot things, the way that I have done it previously in my experience, or I've at least requested in some other places where I didn't have the capability, is that you need to have a very clear snapshot of if you're running on a Linux server, which kernel you were running on. What was the exact version of the software that was running alongside your application and also your virtual machine. So when you do a release that went into production and everything was working fine, you need to know exactly what was the version of your applications, right? That's one thing. So that when you do a release, then you can measure that if there is more abnormal memory consumption, then you are able to justify, because then you can do a diff between the current version. You might not know, but there might have been an upgrade through the sysadmin teams, and they might have bumped up a version of a given software, right? So that's one lead to be able to correctly identify what could be the source of your problem, because you might be thinking there's a regression, and you might get all your heap dumps, your thread dump, etc. But the problem might be elsewhere. That's one thing, right? The second thing is that do you capture very closely when your application is running between two releases? Have you captured what was the memory behavior over time, right? Because if you're not minutely looking at the CPU cycle and memory, just only one version is all you need, right? Because if at some point your production version did not have a regression, you're happy with it, most likely, right?
Yes.
So whatever your snapshot is giving you between that time and the next release that goes in, and for you to be able to see if there's a regression or not, right, is your latest data. When you go to the doctors, you do not show him your blood report 2 years ago, right? You show him the most latest blood report, right? So if you're not doing that, then I would personally recommend that you start doing that, right? You have to know exactly what are the versions of the software running on your machine. Now the next thing is also, is just simply that there is no problem, it's just that you did not size your software correctly, right? And that's also something that's more business related. Are you expecting to onboard new business features? Are you going to be, I come from a financial background, if we are introducing 2 new financial products, right, that we intend, because we're going to be onboarding a new client, and we had like a 20 gig heap, we might need to bump it to 25, right? And obviously if you run it, it's not, there has been no regression, it's just that we did not plan carefully what was required, right? If you're capturing your historical metrics and you're oblivious of that fact when capturing the data, or if you do not have, let's say, a tag or a release number to look back at what were the features of all the features that went into this version, how would you know, right?
So
Are you, because I kind of agree, but not entirely. I'll say, because you have a problem right now, so you need to diagnose it. It could give some hints to look at what was the previous version, so was there code changes, was there features, something like that, but it quickly gets a bit funny to know what's the real cause. Your example was really good. If there was new feature added, new features added, and there was, I don't know, so new features might overload the system, or bugs caused by the addition of new feature might overload the system. The only way I can know which one it is to do my diagnosis on the current system and just find out. So yes, I'll look a bit at what happened right before, because it might gives me an idea to find the solution a bit quicker. But then I still need to check now, in fact.
It goes without saying, absolutely, you're right. It goes without saying that in the moment you also have to look at the regular tools that are given to you to kind of understand what the problem is, right? But that's not only the case. The thing is, often the systems that we're working on are quite complex, right? So there will be feature changes, functionality that will have been added, but chances are that will also bring in more data, right?
yes.
It's not necessarily always the case, obviously, right? Sometimes we just add more functionality, but it's just to work on the same amount of data. But the thing is that it's not only one feature going in for each release, right? It's more about a couple of features going in, and there can be some big changes, right? So to your point that you want to look at there and, you know, right now and there, you want to look at the different data points you have, but if you're seeing an out of memory exception, let's say, right? If you have onboarded a new client with, right? And you also have added new features, knowing also the context will help you go and decide what the problem might be, right? You might be wasting precious time trying to figure out by adding more features and things like that, so that's all.
Okay, so let's address the out-of-memory error situation right now. So you're running your application and you run out of memory. What do you do?
First of all, you wake up because it always happens at midnight.
Yeah, of course. So you wake up because it always happens at midnight. Not necessarily, right? You add more memory. You retune the garbage collector according to the data you had. Okay. And then what do you do again? You let it run. If you run out of memory again...
First of all, you open your GC log.
Yeah, well, that's part of tuning the garbage collector. Yeah, okay. So if you run out of memory again, what do? You add more memory. And you keep adding memory, and after a while you're going to look at it and say, this is a memory leak, and then you're going to go into a memory leak diagnostic. Right? There's nothing about versions, there's nothing about history, there's nothing about anything except for just a process that you're going to follow in reaction to, I have an out of memory issue. And I mean, we've done this time and time again, right? What we looked at it, and we looked at it and say, okay, this system simply does not have enough memory. But I don't care if the load is higher. I don't care if there's a memory leak. I don't care really about anything until I've actually ascertained that the system is out of memory, right? Running out of memory because of a leak. And if it's a slow leak, maybe I don't care, because you can recycle a JVM and move on. Who cares, right? I'll just tune for the worst case. And if it's not a memory leak, eventually we're going to hit memory settings where we're going to settle the system down where that is not going to be a primary problem. And that's really what we're talking about. So first, looking at the system signals, categorizing the types of problems that can create those types of signals in the system, right? Understanding, from that taxonomy, what the possible problems are, what are the tools that are going to help you diagnose what that current situation is, and then and further characterizing it. And as you further characterize it, either you come to the solution and characterize all the things you need to know around it to fix it, or go on to the next tool in the chain in order to get the characterization you need to understand what's going on, right? And that process, as I said, is not strictly imperative, but there is a clear flow and there's a clear decision tree. That means that you're picking up key signals. And this is common with a lot of diagnostic processes, like somebody reviews medicine here before. It's like, you go into the ER, what do they look for? Temperature. Well, they check, make sure you're not leaking too badly.
Pulse.
Yeah.
Tension.
Temperature, pulse, right? And level of consciousness and things, these types of things, right? And if there's problems with those signals, the direction of the problem of those signals will lead the doctors down a certain diagnostic path, and that's what they'll follow. And so if we go into these systems, I think one of the biggest problems we see with companies, and we get involved in tuning with a lot of companies, the biggest problem we see with the internal people is they come to the table with their own bias. And we already have a lot of bias built into how we make observations in the system. It's like, I just told Patricia, we tend to call this what we call street lamp tuning, right? And what we mean by street lamp tuning is when you go to tune, if you lose something in the dark, where's the first place you look? Where the light is, okay? And in the case of our systems, where's the light? Well, those are the things that we've instrumented because maybe those have been the things that give us a problem in the past. But that's generally not an indicator that these are the things that are going to give us problems in the future, right? Because the problems can come from a whole host of situations, which basically means we need to take the performance tuning problem as we see it now. It's just like an infinite space. There's seemingly an infinite number of things that can go wrong, and we need to tip it sideways. And when we tip it sideways, we can see that there's, yes, an infinite number of things that can go wrong, but they can only go wrong in a finite number of ways. So we're going to build a taxonomy based on what those finite number of ways that things go wrong. And the things that will go wrong, normally because you have yet a finite number of resources in the system. And if you look at all of the components that are in the system, because they are at finite levels, you can actually look at consumption levels in these things. And those are the key signals that you want to look at. It's like, what are the consumption levels within the various components within the system? Because then when you start looking at consumption levels, you realize that when you hit certain ratios of consumption, that you're going to basically be oversubscribed to those resources. They can't be renewed fast enough to meet your performance requirements. So you simply don't have enough of them, right? Those will be the fundamental root causes of the performance problems in the system. Now, the next stage in the process is to take that information and map that back to application behavior, whether that be in the operating system or be it in the application itself, right down to maybe whatever specific component is in the whole thing, right? That's how you get to a diagnostic in 15, 20 minutes, maybe 30 minutes, as opposed to randomly poking around, hopefully capturing the signals that may or may not expose the problem, and basically guessing. If you want to know why these exercises go on for, weeks or months or years, it's because without rigor in the process, you're guessing. And if you're guessing, you're going to be wrong and you're going to be right. And as you go through the whole process, right, you want to do things that are going to mean that you're wrong less often, because now it's just rolling the dice. Am I going to find this thing by rolling the dice, or am I going to apply rigor and process to this whole thing to try to make the odds, like stack the odds in my favor and build filters that are going to get rid of whole classes of problems in one shot? And so looking at these signals vertically really means that I can come up with a taxonomy of the types of problems, and I can understand what the patterns are in the signals that actually lead me to each of these different types of classifications of problems that we have. And from there, we can actually move down to profilers that are very well tuned for finding problems that are associated with each of the different categories that we've identified in our taxonomy. And that's really a rigorous process that actually brings success very quickly.
But if you have a signal, and you should know accepted value of signal, yes?
Sorry?
You should know what value is accepted for the signal like this.
Yeah,
what is
certainly
the correct temperature of your body?
Right, absolutely. Those
but
are.
In your system, you may record a lot of.
Okay, I'll give you a magic
like
number. You want me to give you a magic number right now? Okay, so
No.
magic number for human temperatures like 98.6 degrees, 37 degrees Celsius, whatever you want. And you can go plus or minus a couple of degrees and everything is good, right?
Yes.
That's why some
Okay,
networking tools
so
will-
I'll give you an equivalent magic number for a Java application running on, or Java applications running on a machine. User to kernel CPU utilization should not exceed 10%. Okay? So it's a magic number, but as soon as you exceed the 10% kernel to user ratio, then your system is in trouble. It will have very limited scalability. Okay, so yes, you're not going to get that magic number yourself unless you've looked at a lot of systems and gone through a lot of work and stuff like that. But now that we have the magic number, we can apply that as a diagnostic. It's the same thing as, if you don't know the 98.6 number, but that 10%, which is fuzzy because it fluctuates depending on other conditions, we can use that number. And that can help us categorize the type of problem that our system is actually facing. And that's a cheap metric to get, and I don't care that much about historically what's going on, because I just know that if I'm outside of that threshold, I have an issue.
Well,
That's simply all there is to it.
well, it's too easy to.
Talking about two different things.
Not really. We're talking about applying a...
You're right, and they're right.
Meaning?
Meaning that, yes, when there is a crash, you want to understand why, that's your answer.
It's too late. If it's crashed, it's too late. You're not going to understand why.
Sure. Okay, so maybe they do this process before, in advance, whatever. But often the root cause of the problem is a badly designed application. And
Generally always the case.
okay, so they want to know that.
But
So-
that's part of okay, so
There's other tools which
Well,
tell you without waiting for a crash, you can even use them probably in
But
debugging.
if it works, it's not badly designed, it works.
No, if it works,
Or I don't care about
if it works, but does 1,000 calls to the database instead of one, yes, it works, but this you can find out at unit testing. You don't have to wait for it to crash.
yeah, I mean, you're completely right about that particular point, but
That's a very common bug.
if it's making 1,000 calls to the database and it meets my SLAs, I don't really care. I have other things that I'm more concerned about.
unless you
But
want to save electricity
daycare,
or...
because come Christmas, the system will crash.
Okay, so now we're talking about, do they have any scalability? And that
Yeah.
should come out in other types of testing, right? So I don't really care if it's meeting their SLAs, but what you're saying is that that's not going to meet their SLAs.
Yes, but that's a generalization.
That's not a generalization. That's exactly how we tune. If you're meeting the SLAs, we're done. If there's no scalability, then you're not going to meet your SLAs. To me, that's the stopping point. As soon as I met the SLAs, no one's paying me anymore. I'm out of there. I'm done.
So, for me, if the application works, then I can be asked, okay, we do too much queries to the database, so I need too much Oracle license, so I need to be more efficient, then it's some other tuning.
That's a different
Or I
issue.
need less electricity spent, okay, I'll tune for that as well, but if it works, nobody complains, I'm kind of happy.
I don't buy that.
You know, that's the way most of the world works, and they work
I know.
because they're busy building features, and if it's working, meeting their SLAs, they'd rather be building features than rather be making what already works work faster. I mean, and
And then they call me at 10 o'clock at night because it didn't meet their SLA.
well, okay, that's a different issue. But but the point is that and I mean, to your point, there's perfectly good economic reasons to make sure that the thing is performing as well as possible. If you look at Twitter and Google, they're estimating the cost of moving from CMS to the G1 collector is about 20% bump increase in their power bill, just for the running their data centers. Okay, so to me, that's, you know, at a budget as big as you can imagine they have for running their data centers, you could say that's a pretty good economic reason to decide to
Stay on Java 8.
right. And actually, I would say that Electron budgets are just as important today as time budgets are. You know, not just for mobile devices, but actually for servers also.
Okay, so this is the time where you wrap up and then tell everyone what great learnings they had in the session.
That's your job.
It's hard to do a roll-up of Kirk's talk now, but probably main idea is that monitoring is different in different cases.